Good day everyone. Welcome to all. My name is Sachin Ahankari, working as Assistant Professor in Narasimha Reddy Engineering College in EC department. So today in this session we will see the basic information regarding the op-amp. So before going to op-amp, we must know uh, about differential amplifier. So differential amplifier, the name itself suggests that it is going to amplify the difference between two input voltages. So whenever two input voltages are applied to the differential input voltage, the difference is amplified, and amplified difference voltage is available at the output of your differential amplifier. For proper functioning of differential amplifier, transistor Q1 and Q2 must match properly. Must match properly in the sense their beta must be equal, their VBE must be equal. So two transistors must have the same beta and same VBE. So beta is a current gain of common emitter amplifier, and beta is equal to IC divided by IB. So IC divided by IB must be same for both the transistors, as well as base to emitter junction voltage for cut-in voltage for both the transistors must be equal for the proper operation of the differential amplifier. So depending on the how input voltages are applied and how output voltages are taken out, depending on that there are four types of differential amplifier, that is single input balanced output, single input unbalanced output, dual input balanced output, and dual input unbalanced output. So here the input voltages is applied here to the V1, and here the V2 is grounded. So that's why it is called as a single input. You are applying only sinusoidal wave here at V1. Therefore it is a single input, and since the output is taken from the two collectors, it is balanced output. Or if you are going to cut the differential amplifier in between, in the middle, you are taking the output from the C1 and C2, and if you are going to cut, they will match on each other. So symmetrical configuration is there. That's why if you are taking the output from C1 and C2, it is called as a balanced output. And if you are taking the output from C1 and ground, or C2 and ground, then that output is called as unbalanced output. So here it is a single input and balanced output, and here it is a single input and unbalanced output, because you are applying input voltage to the base of transistor Q1 only, and the base of transistor Q2 is grounded. So single input, and since the output is taken from C2 and ground, therefore it is unbalanced output. So if you take the output from C1 and ground also, at that time also it is a unbalanced output. So for dual input balanced output, the V2 is applied here. Instead of grounding this base, you are applying the voltage V2 here, and you are taking the output, that is dual input and balanced output. And if you apply the voltage V2 here at the base of transistor Q2, then both the voltages are applied here. That's why it is called as a dual input, and since the output is taken from the C2 and ground, or C1 and ground, so it is unbalanced output. So if you apply V2, it will be dual input unbalanced output. So in that fashion, you are going to construct the differential amplifier, and the output voltage is directly proportional to the difference between the two voltages. So if I apply V2 here, V0 is directly proportional to the difference between V1 minus V2. So uh, here V0 is directly proportional to V1 minus V2. So if you remove the proportionality constant there, then V0 is equal to A into V1 minus V2. So A is a proportionality constant, and it is also called as open loop voltage gain of the differential amplifier. So if I go for the uh, which terminal is non-inverting input terminal and which terminal is inverting input terminal here. So here the output of differential output voltage is given by AD. AD is open loop voltage gain or differential voltage gain uh, into V1 minus V2. So V0 is equal to AD into V1 minus V2 here, and when V2 is 0, then V0 is equal to, if I am going to put V2 is equal to 0 here, V0 is equal to AD into V1. So the output voltage is in phase with your V1, and if V1 is grounded, then V0 is equal to, if you put V1 is equal to 0 here, then V0 is equal to minus of AD into V2. So here the output voltage is in phase with V1 and the output voltage is out of phase with V2. Therefore the terminal to which V1 is applied is called as non-inverting input terminal, because it is in phase with your V0 and it is out of phase with your V0. Therefore the terminal to which V1 is applied is called as non-inverting input terminal. So here V1 uh, to which this voltage is applied. So whenever if V2 is grounded, then at that time this V0 is in phase with V1. Therefore the V1 is non-inverting input terminal, and V2 is inverting input terminal. So here V2 is out of phase with, therefore V2 is inverting input terminal. So if you go for uh, so this is about a differential amplifier. If I go for the pin diagram of op-amp, it is a dual inline package pin. It is 8-pin dual inline package. The first pin is offset null, second is inverting input terminal, third is non-inverting input terminal, fourth is minus of VEE and offset null. Uh, Pin number 6 is output, pin number 7 is plus VCC, and pin number 8 is no connection pin. So in this fashion there are 8 pins of the op-amp for 741 IC, and op-amp is nothing but in the block diagram of op-amp, the first 2 or 3 blocks are differential amplifiers. uh, they are for one type of differential amplifier is followed by another type of differential amplifier. In that fashion 2 or 3 stages of differential amplifiers are there, and after 2 or 3 stages of differential amplifier you are having the level translator circuit, and level translator circuit is there, and after that there is a output stage, that is complementary symmetry push pull amplifier is used at the output stage. So in the block diagram, the first stage of differential amplifier is dual input balanced output differential amplifier. The second stage is dual input unbalanced output differential amplifier, and the third stage is a level translator circuit, which is used to shift the DC voltage. Because of the direct coupling between the first two stages, DC level at the emitters goes on increasing, and this DC level should be brought to 0 volt for proper functioning. That's why we are using the level translator circuit as a third stage, and the fourth stage is complementary symmetry push pull amplifier. This stage is used since it provides a large voltage swing across the output. That's why we are using. So here various types of differential amplifiers are there in the op-amp. So we will see block diagram and all these things in the next lecture. So here Just I am giving the brief idea about the op amp. That is a pin diagram. This is a pin diagram of op amp. Now I will see or we shall go towards in how many ways we are going to, what are the modes of op amp, in which modes the op amp can be operated here. We are going to see that one. So the modes of op amp, there are three types of modes are available in the op amp. The first type of mode is first type is single-ended mode. So single-ended mode, double-ended mode, or differential mode. It is also called as a differential mode. Single-ended mode, double-ended mode, and common mode. So these are the three modes of the op amp in which the op amp is operated. So I will give just some idea about op amp. So operational amplifier is a uh, DC coupled high gain electronic voltage amplifier with differential input, and usually it is a single ended output. The operational amplifier is a direct coupled high gain amplifier. The gain of operational amplifier is enormous. It is very high. So it is a direct coupled high gain amplifier consisting of one or more stages of differential amplifier followed by the level translator circuit and an output stage. So it is a versatile device that can be used to amplify AC as well as DC input signal. So why it is called as a operational amplifier? So it is called as an amplifier because it is going to amplify both the signals, that is AC signal as well as DC signal can be amplified with the help of this amplifier. That's why it is called as an amplifier. And OP is a that is operational amplifier. It performs various mathematical operations or mathematical operations such as addition, subtraction, multiplication, integration, differentiation, logarithmic and anti-log operations. Apart from these mathematical operations, it is used for various other operations also, like filtering operation, sample and hold circuit operation. Uh, the various operations are performed apart from the mathematical operations. So that's why it is called as a operational amplifier. So if I go for the ideas, the basic ideas, the operational amplifier is a direct coupled high gain amplifier uh, which is usable from 0 to 1 megahertz, to which feedback is added to control its overall response characteristics, that is gain and bandwidth is controlled, and the op amp exhibits the gain down to 0 frequency. So here such DC amplifiers uh, uh, we are using direct coupled amplifier. So here they are not they don't use blocking capacitors like coupling capacitors or bypass capacitors are not used in the fabrication process of the op amp. Why they are not used? Because if you use the coupling capacitor in the fabrication process, then it will reduce the amplification to 0 at the 0 frequency. So at 0 frequency means it is for DC, it will not amplify if you attach the coupling capacitor at the differential amplifier using transistors. So that's why we are not using capacitors in the fabrication process here, or inside the inside the op amp, or very less capacitances are used there. We are not using any coupling capacitor over there, and we are also not using the bypass capacitor. Large bypass capacitors may be used, but it is not possible to fabricate the large capacitors on the IC chip and the capacitors fabricated are usually less than 20 picofarad. So whatever the capacitors you are fabricating inside the IC is less than 20 picofarad, and the transistors and diodes and resistors are also fabricated on the same chip. You are also not going to fabricate the inductor, because within short area you cannot develop the magnetic field. That's why you cannot fabricate the inductors, or you cannot fabricate the capacitors more than 20 picofarad. So this is about the basic information. Again, in the next lecture, I will give some other basic information about the op amp, and we shall stop here. Thank you.